So hello friends, our today's question is question number 172, which is factorial trailing zeros, and it is a very important question if you are especially a math student and a science student. So if you have learned the science, not science, but maths carefully, but if you are specially uh, preparing for any competitive exam, so this concept is easy for you. But if you are also a board student or any topper one, so also you can you should know. But let's see what it is saying. So our question is, given integer n, return the number of trailing zeros in n factorial. So n factorial, we know that, all know that, if you have studied math, so you should know what is n factorial. N is factorial here is n into n times n minus 1 times n minus 2 till will go up to 1. So let's say our n is 3, so our output will be 0 because 3 factorial is equal to 6 and it has no trailing zeros. Now let's say our n is 5, so our answer would be 1 because 5 factorial is 120 and it has one trailing 0. And when n is 0, our output is 0 because we know that 0 factorial is 1. So how we will approach this? So to approach this question, you all should know that 0 factorial is 1, then 1 factorial is 1, 2 factorial is 2, 3 factorial is 3, 6, 4 factorial, we all know that it is 24. Until this all were going good, but when 5 come, what did the 5 do? 5 factorial is 120 because we know that 5 factorial is nothing but 5 times 4 times 3 times 2 times 1, which multiply up to 120. So from 5, if we will go ahead and check that 6 factorial is 720, then we will check that 7 factorial is 5040, then it will continue till 8 factorial also, 9 factorial also, and 10 factorial also. It will continue till, because till 4 no 0 was coming at the trail, or no 0 was coming at the last, but from 5 it will start coming at least 1 0. It should be, there should be an at least 1 0 at last, because 5 factorial is 120 here, and all the further numbers would be multiplied. Like 6 factorial is, we know that 6 times 5 factorial also. So 5 factorial, we know the 120, 120 times 6 is 720. So it will continue and will come at least 1 0 after the starting from 5th and will continue till infinity. At least there would be a 0 at the trail space, like at the very last. Now we need to check that for a particular given number n, we need to find that how much trailing zeros it has. So to find this, what we will do? First we will take count variable, and we know that we will initialize to 0 as we do in every question if we need to find any count. Now the main concept comes here is, we know that every trailed 0 starts from 5. So first we don't know how much iterations we have to do here, so again we will loop a while loop, use a while loop here, and we will check that if the number is greater than 0 or not, because negative factorials are not defined as you have studied previously. And what we will do, if n is greater than 0, after this condition is executed, now we have important step here. Since we know that from 5 the 0 starts coming at the very last, there would be at least 1 0 at the very last starting from 5 and will go up to infinity. Now the n we will do here, n is equals to n divided by 5. So this step is very crucial here and very important. Why this is important? And let me explain. So when n is n equals to 5, what we will do, we will increment that particular count, and at last we will return just count. Now let's take an example of a number. So I am taking example of a number 6 for small, then we will go ahead and take a big number. So 6 will go here and this condition will be matched. Now what we will 6 do? The 6 divided by 5 will be 1 because it here is n, so n would be 1 and count will be incremented to 1. Here we have not incremented the count like count plus plus because it will increment only 1 because we know we need to find that how much trailing zeros are there, not we need to find that how much number is there. So to find trailing zeros I have done this step count plus equal to n. So let's take a bigger number, let's say I have 20. So we need to find how much trailing zeros would be there at the very end of the 20 factorial. So 20 would be equal to 20 divided by 5. So 20 divided by 5 will be equal to 4. So now count will be incremented to 4. Now again this will go here and 4 divided by 5 which will not happen. So this would be not executed and count would be 4 also. So we know that at the very end there would be 4 zeros. Now let's say in 10, I know that in 10 there is a 2 or 3. Let's see, it's 2 only. Its value is something 362800. 10 factorial is this. So let's see if this condition matches for our this code basically, or this solution matches for this 10. We know that answer is 2. Now let's see. So 10 will go here inside the while loop and the n would be come here like a 10 divided by 5 would be equal to 2 and so count will be incremented to 2 here. So count would be equal to 2. Now the trailing zeros will be 2 because 2 divided by 5 will not happen at the very end. We have return count, so our answer would be 2 here. So this was the solution. Our solution matches with this 10 and we know that the value of 10 factorial is this and that trailing zeros are 2. Our answer is also 2. So our solution matches for this 10. Now let's take for 9. We know that 9 variable is this divided by 10, so it is 36280. Answer is 1. Let's see. 9 divided by 5, which would be like 2 point something, so it will be 2 here. Not 2, it will be 1 here. So our answer would be 2 here. Now let's do the code. So it would be int. First thing we will make a count variable and now to find the trailing zeros we will check that the number is greater than 0 because negative factorials are not defined. And what we will do, just we have to divide the number every time by 5 because we know that from the starting with 5 every 0 comes at least 1 0 because 4 factorial is 24 and 5 factorial is 120. We divided every number with 5 and will increment in the count when it is divided by 5. Why 5? Again I will tell you that starting with 5 factorial there must be at least 1 0 at the very end. So we have divided by 5 and at last we will return count. Now let's run this. Okay, so as you can see here, all the test cases are passed. Now let's submit it and check the results. Okay, it is accepted and all 500 test cases are out of 500 are passed. Our runtime is 0 millisecond and beats are 100%. Memory used here is 8.07 MB and beats are 85.42%. So this was the solution of this question. Thank you.